Now, in this lecture, we will study GPIB, General Purpose Interface Bus, or IEEE 488 bus. Now, here you can see this is the cable, GPIB cable. Now, here this is the connector. Both the sides connectors are connected. One is a female connector and another one is a male connector. So, here you can see the connector, how the look is. If you see here, the shape, it is almost looking like a D. So, that's why we call it as a D connector. This is a 24 pin D connector, and we use this cable widely to enable electronic test equipment to be controlled remotely. So all the electronic equipments are connected to this cable to the computer to control remotely. Now, electronics equipment are divided into three types. First one is the controllers, listeners, and talker. Now, as the name suggests, the controller is the entity that controls the operation of the bus. Usually, it is a computer. Next one is a listener. A listener is an entity connected to the bus that accepts the instructions from the bus. Similarly, now next one is a talker. It is an entity on the bus that issues instructions or data onto the bus. That is called the talker. Now, if you take voltmeter, now voltmeter, it will measure the voltage. But before that, after connecting this voltmeter to the computer, to set the panel or to set at the time of settings, voltmeter acts like a listener. Once the settings are done, then voltmeter will read the data and the data will be placed on the cable, on the data bus. So at the time, the voltmeter acts like a listener. Here, few devices will act like a both a listener and talker. Now we will see the how the structure. Now GPIB instrumentation bus structure. Now this is the bus. So total 24 lines are there. In that 24 lines, 3 lines are the handshaking lines or handshaking bus signals, and 5 are the management bus signals, and 8 data, and 1 is a shield. Shield is nothing but what? The case, the top of the material which is made up of, so it is contacted with that. So 1 is that, and remaining all are ground pins. In that 1 ground pin is a digital ground. So now this is the complete GPIB cable. So for that, how the instruments are connected. Now here you can see. This is, you can take it as a listener or a talker, or a listener and a talker, only listener or talker. Now all the electronic equipment are connected to this bus like this. Now we will see the few specifications or features. Now the IEEE 488 bus length, maximum length is 20 meters. And here we are connecting the total 14 plus 1 controller. Controller is computer, right? 14 plus 1 computer. Total 15 instruments can be connected to this cable. And the distance between instruments, 2 meter average or 4 meter maximum distance. And now here, just now we have seen that 8 data lines, 3 handshaking lines, 5 management lines, and it is a total 24 pin D-type connector, and the maximum data rate is 1 megabyte per second. And these are the features of IEEE 488. Now coming to the advantages. Now this cable is a simple and standard hardware interface, and it interface present on many bench instruments. Now rugged connector, and possible to connect multiple instruments to a single controller. And now coming to the disadvantages, bulky connector, cable reliability is poor and a low bandwidth. We will see the pin diagram. Now, this is the pin diagram for the IEEE 488, and this cable is used for the parallel communication. Now RS-232 is used for the serial communication. Now IEEE 488 is used for the parallel communication. Now here if you see pin number 1 to 12 one side and 13 to 24. Now after completing the 12, again 13 is the top. Here you can see the 4 data lines, and here also you can see the 4 data lines. So totally 8 data lines. And here DAV, data valid, NRFD, not ready for data, NDAC, not data accept. These are the 3 handshaking signals. And EOI, IFC, SRQ, ATN, and REN, written. So these are the 5 management lines or control lines also we can say. And shield is nothing but what? This top, the body is connected to this pin. And the remaining all are the grounds. In that one is a digital ground. So this is about the pin diagram. Now how we will see that how the data transfer takes place. Now here, using this 3 handshaking signals, the data transfer takes place. So how it happens now we will see. So listeners, whichever the listeners are connected to the cable, they use the NRFD and NDAC lines. NRFD is nothing but what? Not ready for data. It will give the status of the listener devices, whether it is ready to accept the data or not. When it is low means what? It is not ready to accept the data. If it is going high means what? Ready to accept the data. Now, whichever the active devices, active listeners are there, so it will it will keep the high signal on this line, thereby what? Those listeners are ready to accept the data. Now, if all the devices are keep this signal high, then only the data is placed on the data bus. Now, after settling the data, it will place the controller will place the data valid signal. If the data valid signal goes low means what? It indicates that the whatever the data is on the data bus is a valid data. Now the listeners can receive this data. So now if NDAC signal is low means what? Now here ready to listen the ready to receive the data. Now after receiving the data, so once the listener receive the after receiving the data, it will make this line high, thereby what? The data is received. So till the last listener makes this line high, then only the next byte will be placed on the data bus. Now this is how the data transfer takes place by using the 3 handshaking signals. Now we will see the general interface management bus lines. So total 5 lines are there. The first one is ATN, attention. If this attention signal is equal to 0, now here you can see the data bus. Now whatever the byte is placed on this data bus, whether this is the data byte or command word, that can be known by using the ATN. If the ATN pin is equal to 0, then the data which is placed on the command, and if this bit is equal to 1, the data which is placed on this data bus is data byte. Now, next one is a SRQ, service request. Now, this pin transmit the interrupt request to the controller. So, if any device need the service or any issue is raised, then by using this pin, it will inform the controller or computer for the service. So now if more number of, if the computer is unable to find out which device is, which listener is asking the service, then at the time, it will go with the polling. If more number of devices are there, then it will poll the devices and it will serve the device. Next one is REN, remote enable. If this pin is equal to 0, then the devices will be controlled remotely, means automatic controlling can be done. If this is equal to 1, then devices can be operated manually. Now, EOI. Just now we have seen that here that multiple bytes can be placed on the data bus. Now, which is the last byte that can be known by using this EOI, end or identify. So end means if multiple data transfer is taking place, now this bit signifies the last byte. So when the talker is, now this will be set by the talker. If the last byte is placed on the data bus, then talker will enable the EOI. Now, and also if multiple request signals are generated, so controller has to poll all the devices which device is requesting. For that polling also, along with the ATN line, by using this EOI, polling can be done. Now, next one is IFS, interface clear. So by using this line, the bus will be, by making this line is equal to 0, the total bus can be reset. At the time, listener and talker, it will not address it. Now the bus will not address it to the listener and talker. So bus will be reset. So it will. Now this is about the IEEE 488 protocol.